Good evening, class. Today we're going to be talking about coterminal angles. Coterminal angles. And so our objective is pretty simple. It's just to find coterminal angles. Now, since already I've used this term coterminal angles before, and I realize you may not have seen this before, I might as well go ahead and define it. So coterminal angles, it's two angles with the same initial and terminal sides but they have different rotations. Two angles with the same initial and terminal sides, but different rotations. Now this is in words. Math speak is always a little bit confusing. Let me go ahead and just illustrate what exactly this means. Okay, so say I had standard coordinate plane, x-axis, starting right here. Say I draw a line right here. And I measure this angle right here, whatever it is. This one I'm just going to call theta. Okay, a coterminal angle from this is going to have the same initial and terminal side. So the initial side is this guy right here. I'll put it in orange. So this is going to be our initial side. And our terminal side, the ending side of our angle, is going to be here, but it's going to have different rotations. So what does this mean? Well, this means that if I do the same coordinate, I've got a couple different possibilities here. I'm just going to map out for you. So say I've got the same initial and terminal sides. So once again, say I go orange here and pink here. But instead of going up in this direction, the positive direction, say I went in the negative direction, like this. Okay, and so instead of theta, say I called this one phi. This is the Greek letter phi, also commonly used to denote angles. So then I could say that theta and phi are coterminal angles. Okay, so that's one possibility. Once again, the pink and the orange are in the exact same position on both of these. In this one I'm measuring from the clockwise direction, and this one I'm measuring from the counterclockwise direction. Okay, the last possibility, and this is actually several possibilities, is once again, say I've got my same pink and orange lines, my same pink and orange terminal sides. And say I'm even still going in the clockwise direction, but say instead of just stopping it there, say I do one complete revolution and come back around. Okay, so this is going to be 360 degrees back around, and then a little bit more, which is going to end up being this exact same amount, theta amount. But if I go all the way around and come back, same initial and terminal sides, just a different angle. Okay, so it's going to be a much larger angle because it's going to be much bigger. So in this case, I'm just going to call this one alpha. That's the Greek letter alpha. So similar to how theta and phi are coterminal angles, so is alpha. I'm just going to put comma alpha as a coterminal angle as well. Okay, let's jump right into some practice problems. This is going to be a little bit easier than the stuff we were talking about yesterday, mostly because the practice problems that I'm going to be giving you guys today are going to be in degrees. And I feel like you guys are a little bit more comfortable with degrees, or the example problems are going to be in degrees. So say the first one, say I give you 420 degrees, and you're assuming that the angles are in standard position, and so you're charged with, just with 420 degrees, find a positive angle less than 360 degrees that is coterminal to 420 degrees. Okay, so right away I'm looking for coterminal angles. So I'm going to say find coterminal angle less than 360 degrees. So right away I can see that this one is 420 degrees. So I'm already sort of violating that. And so all I need to do to figure this out is just take 420 degrees and subtract 360, because I can see 420 is larger than 360. And when I do that, I just end up with 60 degrees. So if I'm going to draw this thing out, starting with my standard coordinates as always, I'm going to draw out first 420 degrees. 420 degrees is going to look like that, right? So this is going to be 420 because it goes all the way around and then goes up 60. And then this one right here is going to be 60 degrees. So the coterminal angle, the 100% correct answer, would just be 60 degrees. 360 or 420 minus 360 is going to be equal to 60. Not too hard. B. Let's jump in. Okay. So that was sort of this scenario over here where we're loop-de-looping still in the clockwise direction. Now we're going to loop-de-loop in the backwards direction. So here I want to start with negative 120 degrees. And same thing, try to find the coterminal angle that's less than 360 degrees. But so negative 120 is technically less than 360. But in this one, I'm looking for something between 0 and 360, right? So somewhere in just like the range without having to do the loop-de-loops. So in order to do this one I took 420 minus 360. I see this one is negative, so I'm going to add 360 to this one. And when I do that, I come up with 240 degrees. And so because we watched yesterday's lecture and we're amazing and awesome and fantastic at plotting things like 240 degrees, okay? So when I go to plot this one, I can say, okay, this is 180 degrees, and then I need to go 60 more degrees to get to 240. Okay, so this right here is going to be 240 degrees. And sure enough, if I did the same thing but in the opposite direction, right here, right? So I hit 90 and I go 30 more degrees. This one is going to be, because I'm going in the negative direction, it's going to be negative. This one is going to be negative 120 degrees. And sure enough, we can see we've got, with both of these instances, we've got the same initial leg right here, and we've got the same terminal side, same final leg right here. Okay, so the orange and the pink are going to be the same for either 240, 120, or 60 and 420. So that's how we find coterminal angles using degrees. Okay, now let's do the same thing. Let's step it up a notch. But instead, let's go ahead and do it with radians. Okay. So the next example, because you guys are comfortable using radians at this point, is I'm doing the exact same thing, but I'm using radians. So I'm going to give you first one is going to be 17 pi divided by 6. 17 pi divided by 6. So if you do some quick math here, you'll realize that 17 divided by 6 is greater than 2, right? So already, if 2 pi is one full revolution, already we're past that. And so I need to go ahead and rewrite this. And you can rewrite it as a mixed fraction. There's a lot of ways to do it. But basically, just how with this one, I started with 420, and I subtracted a full revolution to figure out what the coterminal angle is. I'm going to do that with this one. But instead of subtracting 360 degrees because it's in radians, I need to subtract 2 pi. Now I'm just going to rewrite this. So 2 pi is going to be a mixed fraction. 17 pi divided by 6. Minus, instead of 2 pi, I'm going to multiply top and bottom by 6 and just get 12 pi divided by 6 so that they have common denominators. So now I've got 17 minus 12. We've got 5 pi up top divided by 6. Excellent. So now I'm going to sketch this out, just like I did with the degrees. And so the first thing I'm going to try to figure out is where 5 pi over 6 is. Okay, so I've got my initial side right here, same as before. Now 5 pi over 6, it's not quite 6 pi over 6, which would just be a full pi, but it's greater than pi over 2 right here, so it's going to be firmly rooted in my second quadrant. And so I'm going to go all the way up to pi over 2, and then I'm going to go over here, and it's going to stop right there. So basically I'm just like pi over 6 shy of being at pi, which is right there. Okay, so that's going to be 5 pi over 6. Now, of course, 17 pi over 6, because I took one revolution away, right, then I know that 17 pi over 6 is going to be the same angle measure, except I go one full revolution and I end up there. So this guy right here is 17 pi divided by 6. This guy right here is 5 pi divided by 6. Once again, coterminal angles, coterminal angles. Okay, one more example, one last example, and we'll finish this one up. Okay, so this one's similar to how I had one that looped all the way around this time. And this one I'm going to have negative pi divided by 12. Just like in the previous one we were dealing with degrees, I had negative 120 degrees. Here I got negative pi divided by 12. So I'm going to do the same thing, just like when I had degrees, and it was minus 120 degrees. I'm looking for the coterminal. I add one full revolution to get it into the positive range. I'm going to do the same thing with this one. So I've got negative pi divided by 12. Sorry, let me box my answer here. Negative pi divided by 12 plus, instead of subtracting 2 pi, I'm going to add 2 pi. Add 2 pi. And if you want to do this out on paper, so 12, getting the common denominator, I just get 24 pi divided by 12, multiplying the top sort of and the bottom both by 12. And I end up with 23 pi divided by 12. Now if I'm looking at this, this is really, really close to 2 pi, right? I'm just subtracting just pi divided by 12 from one full revolution. So I know I'm going to go most of the way around, but I'm going to stop just 1/12 short of 2 pi. So looking at this, okay, so going in this direction, going 23 over 12, right? So I know that that's going to be bigger than pi over 2. I know it's going to be bigger than pi. I know it's going to be bigger than 3 pi over 2, but it's going to stop just short, right? So this is going to be my angle right here. This one is going to be 23 pi divided by 12. Sorry, that's my answer. And then just to draw it out again in terms of negative pi divided by 12, so I'm going to start here and I'm just going to go back. Just backwards just a little bit, and it's going to be negative pi divided by 12. Excellent. Hopefully that helps to explain coterminal angles. Now, of course, things get a little bit more complicated when you start doing, you can combine the idea of a positive loop-de-loop, so one full revolution around in the positive direction, but instead of, say, positive 17 pi divided by 6, you end up with negative 17 pi divided by 6. So you'll end up finding the coterminal angle going the opposite direction. Eventually it stops, and you'll end up with some sort of number between 0 and 360 or 0 and 2 pi, right? So it's just going to be sort of simplifying what that coterminal angle is. Okay, if you have any questions, be sure to bring them to class tomorrow. I'll see you guys then.